So another probability rule is multiplication rule with independence. It's also sometimes called the multiplication rule with replacement. This is going to be important for when we talk about sampling from a population. So basically to find the probability of getting multiple outcomes, and these are multiple outcomes that are independent, that do not affect each other. All we do is multiply them. So if I flip a coin, and I'll go to an example here, but if I flip a coin, the first time I have a 50% chance of getting heads and I have a 50% chance of getting a tails. If I flip it again, I again have a 50% chance of getting tails and a 50% chance of getting heads. So what I got before doesn't have any effect on what I got the second time. But let's say that I was randomly assigning different candy to you, and I gave you the candy, and then I randomly selected a candy from what was left over. That would depend on what happened the first time. So that's a different rule. So the multiplication rule with independence is specifically talking about what happens if the options are the same every time. So the probability does not change. So this multiplication with independence, we have the same probability each time. So as an example, when we flip a coin with heads and tails, so the first time we flip the coin, we're going to get a 0.5. The second time, we have a 0.5 or a 50% chance of getting heads versus tails every time because it doesn't change. They're independent flips. And so imagine that I said, hey, I want to know the probability that I'm going to flip heads and then heads again. Or I want to know the probability that I'm going to flip heads and then get tails the second time. That's what we're talking about. Now, when you have multiple events, your probability of two events is going to be lower than getting just one event because it's more complicated to get two events, right? You have more options. So if I flip ahead the first time, I get 0.5, right? And then if I flip heads the second time, that also has a 0.5 chance or 0.5 probability. So what I would do with that multiplication rule with independence is I just multiply those together to know what the probability would be before flipping. So if I had said, what is the probability that I'm going to now flip a heads and then a heads again? Then I would say, okay, my probability, and you can do this two different ways. So you can either say 1 over 2, because heads is one probability out of two total options. And I'm going to multiply that by getting heads again, which would again be 1 out of 2. You can just multiply across as a fraction. And so then that would be 1 over 4. And then you can divide that and you get 0.25. The other option is that you can calculate it out. And so if we had 0.5 or if we had 1 divided by 2, because we had one chance of getting heads over total chances of 2 is 0.5. We multiply that by 0.5 because we have the same chance each time. And that's going to be 0.25. And so now, again, you can see that that chance has decreased. The probability of getting a heads and followed by another heads is 0.25. Looking at this another way, let's say we want to know what the probability is of getting a heads and then a tails. In this case, the probability is the same. For the multiplication rule, the probabilities may be different, but the idea is still the same, that you're multiplying just straight across. So the probability of getting a heads and then a tails is the same as what it was for getting a heads and then a heads. The probability of getting a tails and then getting a heads is the same. So we're just multiplying that across. We're looking at each probability and multiplying that across. And then the last one here, the probability of getting a tails and then another tails, we're just multiplying each of those probabilities. We're treating them as independent events and we're just multiplying across. Oops, we're not there yet. So you do have some practice activities with this, and then just reach out if you have any questions. And then you're going to next talk about multiplication rule without independence. So before you move on to that, make sure that you understand with independence.